Okay, we're starting off with the problem statement. The crane lifts the 700 kilogram bin with an initial acceleration of 3 meters per second squared. Determine the force in each of the supporting cables due to this motion. The sketch is given below, and as we can kind of observe in this sketch, we want to determine the force in the supporting cables. The supporting cables would be cable BA and BC. Information given about those cables is that they're at a slope of a 5, 4, 3 triangle where 5 is the slope and 4 is the upwards y direction, x is 3. With this, we're going to start off with understanding that we'll want to determine the force in BO before we can determine the force in BA and BC. To start off with that, we're going to do a summation of the forces in the y. But one small step before that also is recalling that force is going to equal mass times acceleration. This will be kind of important. After we recall that information, let us sketch a quick free body diagram. Start off with marking this up here, the little hook, as O. He has a little line coming down. Make it cut in a row. This is now force BO. Come off the sides, and this is point B, this is point A, point C on the crate. As we draw a little crate, we know that it's a 5, 4, 3 triangle, but we also want to add in to this that we have a mass times gravity. And since our mass is 700 kilograms, it'll be 700 kilograms times 9.81, since we're in metric and not US units. So we'll start off with the summation in the y. We're going to call upward positive y into the right positive x. So upwards positive summation of forces in the y is going to equal mass times acceleration in the y. Force BO is going to be equal to mass times gravity plus MAY. We determine this by understanding that force in the y will include this force BO going in the upwards positive direction, and the mass times gravity is going in the downwards negative direction. Since force BO is positive, mg is negative, that will equal mass times acceleration in the y. We subtracted mg from, we added mg from force BO to cancel it out and moved it to the other side. From here, we could take mass and pull it out front. So that way, that's kind of what that is. Consider y a subscript in this matter, just because we're summing forces in the y, acceleration in the y. We know all of these in the equation, so we know what mass is, we know what gravity is, and we know what the acceleration is. So mass is 700 kilograms times 9.81 plus 3. If we add those together, it would be 12.81 times 700. This will give us a resulting force BO equaling 8,967 newtons. We're going to note that over here so we don't forget. It goes 8,967 newtons. Now for the second part, we'll treat it as kind of an equilibrium problem. And our particle equilibrium will take the particle being point B and going kind of around that. So if we do a second sketch really quick, we'll do it in this bottom left corner. This red dot is our point B, and we're going to treat it as a particle. So we have a force going up, which is force BO, and we have a force going down to the left, and that's force BA, down and to the right, and that's force BC. We know that They both have a slope of a 5, 4, 3 triangle. And we're going to work with that. So once we do that, we'll say go back over to the right hand side. We'll do a summation of forces in the x direction. Since it's a particle equilibrium problem, that would take us back to statics, which means it has to be in equilibrium, so the summation of the forces in the x will equal 0. From there, we'll say 3/5 FAB, and we say 3/5 FAB because this here is in the x, 3 is in the x, and that will be over 5 because it's the hypotenuse. So it'll be 3/5 of times force AB is going to be equal to 3/5 for the same reason, force BC. Now the fun part about this is we get to cancel out the 3/5 because if you divide by 3/5 on one side, you'll multiply it by 5/5 on the other side, and this will cancel straight out like that. So now we can state that force AB equals force BC, which kind of makes sense when you think about it, given that there are two ropes at an equal distance at an equal slope going up, and they're both supporting the weight of a crate, converging in a single point. Now we're gonna do a particle equilibrium for forces on the y. Summation of forces on the y is going to equal MAY. So now we have summation of the forces is going to be equal to 4/5 force AB plus 4/5 force BC minus MG. And this will also equal MAY because in our previous statement here. Now we can go to our next, which will be just solving and simplifying. So to solve and simplify, our next one will be, since we know and we've made the statement that FAB equals FAC, we can say that this is 2 times one or the other. And it doesn't really matter which one that you say. So I'm just going to say that it is 2 times 4/5 FAB minus MG equals MAY. Now that we've substituted this, we've substituted this in here, given our previous statement that they're equal, we can go through and now say that this is equal to 8/5 FAB equals MG plus MAY. 8/5 force AB equals M times gravity plus acceleration in the y. And now, since we know a lot of these, we can finally say force AB equals 5/8. Remember, dividing by a fraction, just flip it and multiply. It's going to be 5/8 times n times g plus acceleration in the y, and I'm running out of room. I'm going to go this way. Now we can kind of plug and solve. We know what mass is, we know what acceleration of gravity is, and we know what the acceleration of the problem is. So force AB will be equal to 5/8 times mass, which is 700 kilograms, times 9.81 plus 3. If you plug all of that into a calculator, you'll end up with 5604 newtons is force AB. And we also have previously stated that force AB equals force BC, so we can say force BC, and this is our final answer.